Welcome to another tutorial. In this particular video, we're going to work out partial fractions, and we're also going to see how you can be able to apply partial fractions in terms of integration. So in the first place here, we are supposed to express x plus 3 into x minus 2, x plus 4 in partial fractions. So the solution to this is what we're going to do. Now, if you can look at this question that we have here, it is x plus 3 over x minus 2, x plus 4. This is a proper fraction, so meaning it can be expressed in the form a over x minus 2 plus b over x plus 4, whereby a and b are constants to be found. So in this kind of scenario here, what you are really expected to do in order to work it out, the first thing to do is to ensure that you look at both sides. If we are going to express this as a common denominator, is going to be written as x plus 3 over x minus 2, x plus 4 can be written in a common denominator. I'm using these three lines to imply equivalent. This part can be equivalent to this. So this is going to be, if we're expressing as a common denominator, this is going to be x minus 2, x plus 4, which will mean that if the LCM is x minus 2, x plus 4, then what would you need to multiply by this term here? What do you need to multiply by this term? Actually, I need to show that this is 2 clearly, so that you can see exactly what's supposed to be done. What do you need to multiply by x minus 2 to get this? You can see if you are looking for the term to multiply by x by 2 to get the whole of this, it's actually this part that you need. So meaning you are going to multiply this term at this point. At that step, you multiply this at the next point there. So I believe we are together up to that point. So what I need to do here is to have this as a multiplied to x plus 4 plus b is multiplied to x minus 2. So you see the denominator are the same at this case, so the numerators are going to be the same. So meaning we can be able to write whatever we have at this point with equating only the numerator, the upper part of the equation. Okay, so this is going to be x plus 3 is going to be equivalent to, this is going to be equal to a into x plus 4 plus b into x minus 2. So now that we have this, so we are going to go further. And the approach we're going to use is we need to find these constants a and b. So in order to find these constants a and b, what you are expected to do is to decide when you look in the bracket, for instance, the first bracket, which value should x take in order for this term to be 0. And in that way, we can be able to find the value of b. And in the second scenario, we're going to ask ourselves, which value should x be in order for this part to be 0? Now, for this case, if you take x2, you are going to have 2 minus 2, it will be 0. So the whole of this term is going to cancel out. You remain this so that you can be able to work out the value of a. So to begin with this one, we are going to say let x be equal to -4. So if we let x to be equal to -4, meaning we are going to substitute -4 here, it will be -4 plus 4, and everything is going to run to 0 so that we can be able to find b. So, and that's going to be what? This is going to be, we have said x to be -4, so even on this other side, we shall have -4, -4 plus 3 equals to a into bracket negative 4 plus 4 plus b into negative 4 minus 2. So you can see now this is going to reduce to negative 1 equals to a into 0 plus negative 6b. Now that we have this, we are going to say our negative 6b is equivalent to negative 1. So if we divide by negative 6, divide by negative 6, our b is going to be equal to 1 over 6. So in order to find now a, we're going to say let x be equal to negative 2. And this is going to enable us work out the value of a. So if we let x to be negative, this one, we are going to let x, at this point, we're going to let, x equal to positive 2. So if you substitute 2 here, the whole of this term will run to 0. And now this is going to be 2 plus 3 is equals to a into 2 plus 4 plus b into 2 minus 2. And this is going to reduce to 5 equals to 6a plus b times 0. And therefore our a is going to be, let me just write everything in place. This is going to be 6a equals to 5, which implies that our a is going to be equal to 5 over 6. Now we have gotten the value of a and the value of b. So which means that the expression that you are originally having at this particular point can be written as this is x minus 3 over x minus 2 x plus 3. Yeah, okay, this is actually x plus 3 at this point, can be written as a, we got our value of a, and check really our value of a. In this case, we have gotten it here. This is our value, the value of a. So meaning our expression here can be written as 5 over 6 over what? Over this particular point. This is the part now we are using to express as a partial fraction. The part we are using to express as partial fractions. So this is going to be x minus 2 plus 1 over 6, 1 over 6, which is going to be expressed as what? Over x plus 4. Now this is the partial fraction of this question. So now how do you evaluate the integration part of this? How do you integrate this? Because already we have gotten this in partial fraction can be expressed in that manner. So I want you to show you now how to evaluate this integration at this particular point. Now, because much of the work has been done, we can be able to say this is from, we are actually integrating from 3 all the way to 4, and this is x plus 3 over x minus 2 x plus 4 dx. So we are going to write this partial fraction that we have formed, because now that is more simplified. So we are integrating that expression from 3 all the way to 4, and that is 5 over 6. We write this 5 over 6 over x minus 2 plus 1 over 6 over x plus 4 with respect to x. So now you can be able to integrate term by term, so which will mean that this is going to end up being 5 over 6 ln over x minus 2 plus 1 over 6 ln x plus 4 and the limit of integration, the limit of integration are from actually 3 all the way to 4. So upon substituting this into our formula, we are going to get this expression being written as, let me just move a little bit here so that our can well arranged. So meaning our expression now becomes 5/6 ln x minus 2 plus 1/6 ln x plus 4, and the limit of integration, in this case 3 all the way to 4. Now substituting this in, we are going to have 5/6 plus ln. Now we are substituting 4 minus 2, it will be 2, plus 1/6 ln, substituting 4, it will be ln of 8 minus into bracket 5/6 ln, this is 3 now, that is 3 minus 2 is ln of 1, and plus 1/6 ln, this is 3 plus 4, that's going to be 7. So we can now simplify, and you can be able to put this calculator, and let's see what we are able to get when we put this information in our calculator, and see what I'm having there is actually bracket 5/6 plus, no, this is actually, I think I will be written here as 5/6 ln of what, because we are substituting for ln of 2, not plus, so that's how it should. 5/6 ln of 2 plus 1/6 ln of 8 I close the bracket like that, then minus 5/6 ln of 1, then plus 1/6 ln of what, this is going to be ln of 7, so if I work this, I'm getting 0.599, 0.5999, correct to 4 significant figures. So this final answer here, this particular point is going to be 0.5999. This is given correct to 4 significant figures. So sometimes you may be given these questions and then you are told to give your answer in exact form. So basically you need also to keep on following instructions. So this is one of the questions that you can be asked regarding partial fractions, and which also involve integration. So I want us also to move to question number 2, whereby you are working out partial fractions of a different format, and in that way we'll be able to check if you are given partial fractions of actually this form, what are you going to do? You are told express in partial fractions, x squared minus 3, this is actually question 2, x squared minus 3 over x minus 2 x minus 1 x squared plus 1. So this is x minus 1 x squared plus 1. This is another form of questions that you may be given in order to express them as partial fractions. So what do you need to realize here? There is something that is happening. One at the denominator, one of the factor is actually a quadratic. So if it's actually a quadratic, the expression that you're going to have on the other side is going to be, this is going to be a over x minus 1. Your answer is going to be in this format, a over x minus 1 plus bx plus c over x squared plus 1. So this is the format when you have a quadratic at the denominator you are going to follow, because actually okay, now, and remember, for and another thing that you ought to remember is that this bx, the two constants are going to be on top of the quadratic part. So we can start by saying let okay, we can be able to need to multiply. We need to simplify this and express as a, okay, we need to be procedural. Expressing as a common denominator. This is going to become x squared minus 3 x squared minus 3. Yeah, let me just so that I can monitor. I'm writing this is going to be x squared minus 3 over x minus 1 x squared plus 1, and this is going to be equal to what? In order for you to, of course, on the right hand side, we're going to have x minus 1 x squared plus 1 as the common denominator, but this term is going to be multiplied here and this part multiplied aside, so that we're going to have a into x squared plus 1 then plus b multiplied to x minus 1. So now, since the denominators are equal, it means we can be able to equate the numerators, or you can decide to multiply this term all through so that you can cancel at this given point, and we're going to remain with x squared minus 3 is equal to a into x squared plus 1 plus b into x minus 1. Right, so I believe so when we multiply here, we're going to have as a common denominator, this is going to be x squared minus 3 over x minus 1 into x squared plus 1. It will be equal to a over everything is expressed as a common denominator, x minus 1 into x squared plus 1, so that you are going to multiply this term to come here. This part of the denominator is going to be multiplied. So we are going to have a into squared plus 1 and then plus bx plus c multiplied to the linear part of the denominator 1. So that we're going to have our expression as shown there. So now, since the denominators are equal, then the numerator must also. So we can be able to say this can be expressed as x squared minus 3 is equal to a into x squared plus 1 plus b x plus c multiplied to x minus. Now, in order to find the constant, um, terms A, B, and C, the first thing we need to do is actually to find the constant A. And to find the constant A, we can let x be equal to +1, so that if we put +1 at this particular point, the whole of this term is going to become 0. So that once we have the whole term, we'll be remaining with one unknown. So if we say let x be equal to 1, now our expression is going to become 1 squared minus 3, that's going to be minus 2, is equals to a into 2, because 1 squared plus 1 is 2, plus bx b plus c, because already we have said let x be 1, so already this is going to be plus c, and the whole of this is going to be 0. And now, since this whole term will disappear, we are going to remain with 2a equals to -2, and this implies that our a is going to be -1. So already we know what's the value of a. So the next thing we're going to do is equate coefficients. Equate the coefficient of x squared. Equate coefficients of x squared. Now, in the first term, in this expression, I want you to focus here. In this expression that we have at this particular point here, in this expression here, the coefficient of x squared here is 1. The coefficient of x squared here is 1. So we're going to write 1 at that point is equal. The coefficient of x squared in this second term here is going to be a times x squared. This is a times x squared. So the coefficient of a of x squared here is going to be a. Then plus the coefficient of x squared here, actually x squared will only be obtained if we multiply bx times x. That's when we can be able to get the x squared. So the coefficient in that case, if we multiply this guy and this guy at this particular point, we're going to get bx squared. So the coefficient here is b. And those are the only coefficient of x we expect in this particular question. So I'll want you to now find the value of b, because already we have obtained the value of a at this particular point. So we can be able to say this is going to be 1 is equal to 1 negative plus b, and which implies that our b is going to be equal to 2. So we are done with the constant, the value of b. So we have it, and we are happy with that. Marker is not really working out. I hope now it's working out. So oh, this it's not clear. It's not clear. So what I was saying is that now our b actually is 2, as you can see from this particular point. So the next area now we need to look at is how to find c. And c can be easily found by equating equate the equate the constant terms. In this expression here, there are constant terms we can have, because a, b, and c are constant. So from this original equation that we are having at this particular point, I'll want us to check which constant do we have here, and how can we be able to equate them. Now, for instance, in the left hand side we have one constant, which is -3. So we are going to write that -3 there, and then after the equal sign we have this constant. If you multiply, because we are equating the constant term, so this a of ours is going to be multiplied by 1. We are going to have a, and at this particular point the only way we can have a constant is when we're multiplying c and -1, and that's going to be -c. But since we know what our value of a is, we can say this is -3 equals to -1 minus c. So which implies that our c is going to be equal to 3 minus 1, and our c is going to be as well 2. So which will mean that we can express this as partial fraction, the original equation that we had, and to express this as partial fractions, this is going to be a over x minus 1, and our a we got to be -1 over x minus 1, and then plus b. Our b we got it as 2, so it will be 2x, and our c we got it as 2 plus 2 over x squared plus 1. So this fraction that originally that we were given, that is here, now has been expressed as in partial fractions, So okay, so as I'm trying to look for a different marker that can enable of partial. So we need to look at another type of questions that you asked. And in this type of questions, you'll find that at the denominator, you are going to have one repeated term at the denominator. And let me just write it so that you can really understand exactly what we say. Now here we are having scenario 3, question 3 type of question that you can be asked. Now you are told express as okay in partial fractions, and what are you expressing? You are expressing x minus 1. This is x minus 1 over x plus 1, which is going to be equivalent to over x minus 2, and this is now squared. Now you can see whatever that we are having here is one of the term is squared, meaning one of the term is repeated. And in order to work out this we're going to say this is going to be equivalent to a. This is the format you will be like expressing as partial fraction over 1 x plus 1 plus b over the repeated term, which is x minus 2. Again, you are going to add another constant and write x minus 2, but this time round you'll put the square that you had. So once you've done that, remember the next step that we mentioned. After you've done all this, you are going to expressing as a common denominator. Now, expressing as a common denominator, this is going to be what? This can be written as x minus 1 over x plus 1, x minus 2 squared is going to be equivalent to, now the common denominator in this case is going to be x plus 1, x minus 2 squared, basically because one of these is inside here, so this is the common denominator we're going to have. So which will mean that the first term a will be a into bracket. Now what do you need to multiply by this in order to get what is the denominator here? It's actually x minus 2 squared plus b into x plus 1 x minus 2. This is x minus 2, so this is going to be basically multiplied by, this is going to be multiplied by x minus x plus 1 x minus x. Then the last term is going to be plus c, should be multiplied by x plus 1 x. So what we have just done here, because we have expressed this as a common denominator, so we are going to ask ourselves, what do we need to multiply? I need to check x squared x one. Now since we have the okay, now since the denominator are equal, we can be able to equate the numerators. So this x minus 1, let's write it different times so that we can clearly have a distinction of exactly what up to that. This is going to be written as, this can be written as x minus is equivalent to a into x minus 2 squared plus b into x plus 1 x minus 2 plus c into x plus 1. So we need to start by trying to see if we let x be equal to 2, x be equal to 2, which terms eliminated? Let x equal to 2, you realize that this term where 2 appears, so we are going to remain with 2 minus 1, it will be 1. We shall form an equation. This will be 0. This will be a into 0 plus this has 2 minus 2. So we shall have b going to 0 plus c 2 plus 1, it will be 3. So meaning our expression now becomes our 3c equals to 1, which implies that c is equal to 1 over 3. So already we have 1 over the constant at home. So we need to further and strategize on how to get. So if we let 1 to be negative 1, what's going to happen here? If we let 1 to be negative 1 in this equation, don't forget focusing in this equation at this point. So that's going to mean that the first part of the equation here is going to be what? Let me write here. This is going to be 1 minus 1. So if we let x equal to negative 1, let x be equal to negative 1. In that way, we are going to eliminate the constant b, because we shall have 0 and 0 at this point, and then b and c will be eliminated. We'll be in a position of finding a. So this is going to be minus 1 minus 1, it will be negative 2 is equal to a is going to be minus 1 minus 2, that will be minus 3 squared. That's going to be 9a plus c into 0, that is b into 0, and plus c into 0. So this is going to translate to 9a actually equivalent to negative 2, so which implies that our a is going to be negative 2 over 9. And in order to find b, what are we going to do? In order to find b, what are we going to do? In order to find b, what are we going to do? Yes. So in order to find b, we are going to equate the constant terms. And say we can equate the constant terms, or we can equate the coefficient of x squared, equating the coefficient of x squared on this left hand side. So equating the constant terms, there are different ways you can be able to get it. You can equate the coefficient of the constant terms, and in this case the constant term for the left hand side, constant term here is actually this negative 1 that we put in the negative 1 is equal to the constant term. This one is negative 1, the one that I picked from there, because I was focusing on this. The constant term in this case here, because if you square this term, here, you are going to have positive 4 somewhere. If you square x minus 2 squared, is going to be positive 4 as the last term. So positive 4 times this constant a, we are going to have 4a. And at this particular point, you can have a constant term, and the constant term is going to be 1 positive times negative 2 to be negative 2 times this b to be negative 2b. Yeah, and the last part is going to be plus c, because c times 1 will also be a constant term. So which will mean that because we already know the value of c and we know the value of a, we can substitute them so that we can find the value of b. So this is going to be minus 1 is equals to 4 into a. Our a is negative 2 over 9 minus 2b, and b and our c actually is 1 over 3. So which will mean that this is going to be 8 over 9. 8 over 9 negative 1 equals to a negative 8 over 9 plus 1 over 3 minus 2b minus 2b. And if we work out that, we are going to have take 2b on the other side, going to enter this have here, which will mean that this can be written as 2b is equals to, I've actually taken this on this side, so 1 over 3 minus 8 over 9, 8 over 9, then plus 1. So if we work out this with our calculator, this is having 8 plus 1. So if you work out that and then over 9 divided by 2, that we're going to have 2 over 9 as. So our b is actually 2 over 9 by 0. So having written this, things that have the value of a, b, and c, finally you should not just stop there. You must write the expression as a partial. So which will mean that this expression here in partial fraction can be written as a. Our a, we got it as negative 2 over 9. So this is going to be minus 2 over 9 into x plus 1. I've taken this 9 down because it is a fraction. 9 is down here. So this is x plus 1. Then b, we got b as 2 over 9. So this is going to be plus 2 over 9 into x minus 2. Then plus c. Our c was 1 over 3. So this is going to be 1 over 3 into x minus 2 squared. Now this is the partial fraction of the question that asked to work out. And I believe you've gotten that kind of feeling on how you can go to solve different questions to partial fraction. So there's one other form of partial fractions that you are going to do, whereby you have an improper fraction. And maybe if we work out this, you'll be able to understand basically what we mean. So you have a question like this. Expressing improper fraction in partial fractions. Expressing improper fractions in partial fractions. So this is the kind of question we are talking about. So if you are having x cubed plus 3 of x cubed plus 3 express in partial fraction. Express partial fraction. And whatever that we're expressing in partial fractions is actually x cubed plus 3 all over x plus 1 and x minus 1. So if you look at this question clearly, the power at the denominator and the power at the numerator are different. So we have a higher power at the numerator here. So meaning we have first to make that proper fraction. This is improper fractions. Improper fractions. Now, in order to reduce this first, something that we need to appreciate is that this expression can be x cubed plus 3 all over. If we expand this is going to be x squared, x times -1, and this times this is going to minus 1. This is minus. So which will mean that we can be able to use long division in order to simplify this. This is going to be x cubed plus x squared plus 0. So I want to divide these two so that I can reduce it to improper, to a proper fraction. This is going to be x cubed plus 0 x squared plus 0x plus 3, and this is going to be divided by x squared plus 0x minus 1. So you see, the highest degree or the highest power in this numerator is x power 3. So meaning that x power 2 is 0 and x power 1 is also 0. So that I've included those powers that are not there, so that we can be able to divide this using a long method. So now the first thing you need to ask yourself, which answer will you get if you divide x cubed by x squared? You are going to get x. So you are going to get x at that. So now x times x squared is going to be x cubed. X times 0x is going to be 0x squared. X times minus 1 is going to be minus x. So we are going to subtract this. Subtracting this will run to 0. This will run to 0 as well. And 0x minus x is going to be just x. And now we're going to pull these 3 down. We're going to pull these 3 down, and we shall have plus 3. Okay, plus 3. So meaning if you divide this, the remainder is going to be x plus 3. So meaning that our expression x plus 3 over x plus 1, x minus 1 can be written as this quotient So at this particular point, you can see here we have a remainder. There is a remainder at that given point. So we can now say this type of equation can be now expressed as a remainder over x plus 1, x minus 1. We can now further try to proceed with the equation. Now expressing this as a common denominator, because already here actually is 1. So we can be able to say, how can we express this as a common denominator? The common denominator is going to be x plus 1, x minus 1, x plus 1, x minus 1. So which will mean that here is 1. So meaning we are going to have x multiplied to the 2 terms, x plus 1, x minus 1, This one, the common denominator is x plus 1, x minus 1. So since we have x plus 1, what are we missing there for a? For a into x minus 1, and then for b we are going to have x minus 1 is whatever that we had mentioned in the first question. You multiply this to this term here, and you multiply this term to this one, so that you can express us. Now, since the denominator are equal, the numerator must be equal as well. So x plus 3, x cubed plus 3 is equivalent to x into x. Actually, if you see, this is x plus 1, x minus 1 plus b into x minus 1 going to be a. So plus a into x minus 1 plus b into x plus 1. Now, in order to find the value of a, in order to find the value of a, shall let x be equal to -1, so that if you let x to be equal to -1, the whole of this b will cancel out, the whole of this term will cancel out. So this is going to be -1 cubed to be 1 plus 3 is equal to, this will be 0, the whole of this term will be 0. If you substitute -1 here, you're also multiplying it to be 0 plus into a into bracket x minus 1, that's going to 2, and therefore this is going to be 2 is equivalent to, and our a is going to be -1. So we already have the value a point. We can be able to say, we can move to the next part. Let x be equal to 1. If we let x be equal to 1, means the whole of this term will be 0. So of it 0, a will cancel out because 1 minus 1 will be 0. So we are going to make b. So we shall say 1 squared b, it will be 4 at that case. And then this is going to be equivalent to b to b. So this shows that our b is going to be equal to that case. The next part that we have is finding, yeah, we are done. There's no another term we are finding. So the next thing is place this as common as in partial fraction. So in partial fraction, remember our expression that we partial fraction. This is it. So in partial fraction, x cubed plus 3 all over x plus 1, x minus 2, x minus can be written as x plus x plus a. Our a is negative, going to be -1 over x plus 1 plus our b. Our b is actually 2 over x minus 1. So we have expressed that as partial fraction. So if at all you are given a, then you are expected to integrate, you can actually do this question, because now the question is straightforward, simplified class. So we have said this is the partial fraction of data. So if you are integrating this expression that you are having here, let me just make up that question. As just setting that question, because in exams you may be told to partial fraction in order to integrate. Now, for instance, if you are working out, this is part A, part B, you are told now integrate x cubed plus 3 over x plus 1, x minus 1 x. You know that integrating this you must have expressed as partial fraction at given point. So we are going to integrate x minus 1 over x plus 1 plus 2 over x minus 2 with respect. So when we are integrating this, we are going to integrate term by term. If you integrate x part, so the answer becomes x squared over 2 ln x plus 1 plus 2 ln x minus 10 plus c. This is indefinite integrals, but if you are given the limits, you could have substituted and then you will not be having at that given point. So I